Good morning, students. Welcome to today's activity class. Today I am going to show you some chemical reactions. Uh, First of all, and before starting our today's class, uh, I hope you all know about the live classes. From next week, we are going to have our live classes, and there we can easily interact with. You can easily interact with the teacher, and whatever queries, whatever doubts you have, there you can clear your doubts. Okay, so you just go through the chapter properly, and you note down your doubts. Wherever you are having doubt, you just write it down in a paper, and during the live classes you can clear your doubts. Okay, let's start our today's class. So some chemical reactions. This is our next chapter. Also, after doing this language of chemistry, we are going to start that chapter. But as we have some during the writing of chemical equations, we have gone through a few chemical reactions, so that we are going to do today. So first of all, it's a very easy reaction, and it's a very common one, that is production of hydrogen. How we will produce hydrogen? It's in laboratory. Okay, it is very simple. So let's get the chemical equation or the reaction involved in it. How we will produce hydrogen? For this we need to use zinc, that is granulated zinc, along with dilute H2SO4. Okay, all these things are available in our in laboratory. So this zinc is not pure zinc, this is granulated zinc. That means in granulated zinc we are having copper as impurity. And why we are using this? Because this copper impurity will increase the rate of the reaction, so very fast we will be getting the product. So here zinc sulfate, this will produce Zn plus H2SO4. This sulfate will combine with zinc, so we are getting zinc sulfate salt, okay, in solution, along with hydrogen gas. Okay, so as this is a gas, we know we have to give a upward arrow there. So because of this arrow, we can understand the state of the substance, that is hydrogen is in gaseous form. So let us do this reaction. For this reaction we need these substances. This is granulated zinc. See, this is granulated zinc, and we need dilute sulfuric acid, and we need a test tube. Okay, so in this test tube we are going to take some granulated zinc. A very little amount of granulated zinc we are taking here. We need to break it. So see, it's a small piece of granulated zinc. This we are taking in this test tube, and here we are going to add few drops of dilute sulfuric acid. So here I am adding this. Drop wise we are adding. The reaction has been started. Hope you can see that. Can you see the Can you see the bubbles around the zinc? Some bubbles are there around the zinc. That means the reaction already has been started and hydrogen is producing. Now to trap the hydrogen, we have to, I have keep my thumb in this manner to trap the hydrogen. Okay, so that the hydrogen which is producing, that will remain inside the test tube. And after some time we will be testing the hydrogen using a matchstick. Hydrogen will produce a characteristic pop sound if we put a lighted matchstick inside the test tube. Can you see the vapor inside? Just like a fountain, it's forming a smoky fountain kind of. This is the indication that hydrogen is producing here. So I am placing a cap in this mouth of the test tube so that the hydrogen which is forming, that remain inside the test tube. Okay, so in this manner I am hope you can understand that the reaction has been started and it's going on. As still the reagents are there, so the reaction is going on and it's producing hydrogen continuously. Okay, now slowly I'm using this to keep the test tube, and here I will be lighting a matchstick. You have to be very careful. If you do this reaction at home, you have to be very careful. So just I will be taking out the cap and I will be keeping this. Have you seen the have you got the sound? A pop sound. Just once you will be getting. That is the indication of hydrogen. Okay, again we can place the cap because still hydrogen is producing here. Okay, very a sound is coming. Hope you can understand that the kind of fountain, a smoky fountain is there inside the test tube. And the sound of the production of hydrogen is also there. A very slow sound is there. Okay, again I am keeping it in this manner, and again I will be holding the matchstick, burning matchstick inside the test tube again to get the sound. Once again I am telling that if you do this reaction at your home, be very careful. Got the sound again? Hope you can get the sound of the production of hydrogen also now. This is the sound. I'm keeping it in this manner. This reaction is over, means it's already going on actually, but now we will be doing some other reaction. So let it be in this manner. Next, one more reaction we have discussed during the when we have discussed about the precipitation. Okay, so here for this, to show this reaction, we will take barium chloride, BaCl2. Okay, barium chloride, this is a solution, and here again we are going to use this dilute sulfuric acid. So barium chloride along with dilute sulfuric acid, if we take this two, again we will be getting this barium will combine with sulfate, so we will be getting barium sulfate, BaSO4, okay, along with hydrogen chloride, HCl in solution. This barium chloride, barium sulfate, this will form as a precipitation. Okay, a white precipitation we write PPT in this manner. So a white precipitation we are getting in this form of barium sulfate. So this reaction we are going to do now. We have barium chloride solution here. Okay, we have barium chloride solution. So this barium chloride solution we are going to take in a test tube. Few drops of this solution we are going to take in a test tube. Okay, this much is enough. And in this we are going to add dilute sulfuric acid, H2SO4. Acha, what is dilute? Dilute sulfuric acid means the sulfuric acid, strong or concentrated sulfuric acid is there, that is the strong one. Okay, and to make it light or to make it dilute, or we just add water in it, then we will be getting diluted form of this acid. Okay, so that's why dilute sulfuric acid. So few drop of this acid we are going to add in this barium chloride solution. Have you seen, just adding a drop of sulfuric acid, after adding a drop of sulfuric acid only we are getting the white precipitation. Have you seen at first the color of the barium chloride? You can see the color of barium chloride. This is colorless. Okay, this is colorless. No color is there. Okay, this is colorless, transparent barium chloride. And sulfuric acid, this is also colorless, transparent. Okay, but when we are adding this two, we are getting this hazy white precipitation. Now if we keep this in a stand, or if we keep it in open undisturbed, then we will be getting the precipitation. Already we have got the precipitation at down. This is here we have already got the precipitation. Okay, so this is the precipitation of barium sulfate. So as it has been settled down, that's why we are using this downward arrow to show the precipitation. Okay, so this is This is the precipitation. It's clearly visible. Two layers are there. The upper layer, the watery part is there, and the lower layer, the precipitation, the white solid is there. Okay. So that's it. Next, another precipitation reaction we are going to do now, that is with silver nitrate solution, AgNO3. Okay, silver nitrate solution, and here we are going to use dilute hydrochloric acid, dilute HCl. So what we are going to get here, chlorine will add with silver, so we are going to get AgCl as precipitation. This also as white precipitation we are going to get white PPT of silver chloride, and here this silver chloride will form a Cardi white precipitation. Okay, what is Cardi white precipitation? That when we are going to do that, we can easily understand this. So along with silver chloride we are getting HNO3. Okay, AgCl plus HNO3. Now let's do this reaction. For this we need silver nitrate, AgNO3 solution, and dilute hydrochloric acid. Okay, dilute hydrochloric acid. So first of all we are going to take some silver nitrate in a test tube, few drops of silver nitrate solution in a test tube. Okay, this much is enough. Okay, this much of silver nitrate. Next, in this we are going to add this dilute hydrochloric acid. See, this hydrochloric acid is also in diluted form, as we have seen for sulfuric acid, H2SO4. The same one, in the same manner we are getting the diluted form of hydrochloric acid also. So few drop of this. Acha, before adding this you can see the clear or the transparent color of this solution. HCl is also colorless, transparent. Now we are going to add this. I have added just one drop of it. Have you seen the white precipitation? Few more drops we can add. Achha. Now see, this precipitation is, it's getting separated from the solution. Okay, if you see this, it's getting separated just like curd, it's getting separated from the solution. Hope you can understand this. Okay, that's why this is called Cardi white precipitation. Okay, as we are having curd, so the curd is getting separated from the watery part of the milk, watery part of the curd. So in the same manner here also we are getting the watery part, the solution, and the precipitation separated in this manner. That's why it is called Cardi white precipitation. Okay, this precipitation of silver chloride, AgCl. So that's it. So our today's class I'm ending here. Soon we will be meeting through live classes. So till then, have a good day and keep studying.